Alright, section 7.6 homework help. I'm going to look at two problems today. Going to take a look at one that asks us to graph the region and find any max or min values for, and they give us the objective function, and then they give us the list of constraints or the inequalities that they want us to graph. So we'll graph that out. We'll find the feasible region, we call it, or do the shading, and then we'll find the vertices and plug the vertices into the objective function to figure out which one gives me a max or min. And then the other one I'm going to take a look at is basically doing the same thing, only this time you're given a story problem. So you'll have to be able to pull out the inequalities and then go from there. Alright, so back to the first one. Going to ask us to graph and then find any max or min values, or when they say find the feasible region, that means graph and find the shaded region. So I'm going to go ahead and give myself a graph here. Now before I get carried away and start graphing, a lot of times I look at my inequalities and I always want to have them solved for y if they have y in them. So I'm just going to rewrite them or list them over here. Obviously the first two I don't have to do anything with, and remember, like I said before, I like numbering them. This is the time that I like doing it, so I can go back and figure out which equation or inequality it was coming from. So imagine now if I solve that for y, I'd have to subtract x, divide by 2. So my third inequality is going to be y is less than or equal to, remember I'm subtracting x and then dividing by 2, so that would end up being -1 and then 1/2. Dividing the 40 by 2 should give me 20. And then my fourth inequality, if I subtract the 2x, divide by 3, I'm going to get y is greater than or equal to, that'll be -2/3 x, and then also divide that by 3, and that should end up giving me 36, I believe it is. Alright, so, sorry, not 36, but it should end up being 24. Alright, so now I've got my inequalities all written out, and the reason that I like doing that, for a couple reasons. One, when you graph it, you're going to want it as y is equal to. The second reason is most of our problems that we're doing are going to be in the first quadrant. They'll have those too. And so I really want to pay attention to the y-intercept. So when I graph this, I'm going to go ahead and give myself a graph. Again, I know it's in the first quadrants, so I don't need to get carried away making the second, third, or fourth quadrant look all that large. I need to make sure that I cover the largest y-intercept number, so I can see that whatever I do for my numbering, I need to at least make sure I get to 24. Now if you can, try to be as uniform as possible with these tick marks. Your graph needs to be fairly accurate, or you might be just a little bit off, and it can actually affect it quite a bit. So I'm going to go by 2s, so I'm going to make sure I have 12 tick marks here. 4, 5, 6, 7, 8, 9, 10, 11, 12. You can easily go by 1s, 3s, 4s, whatever you kind of want to. Like I said, I'm going to go by 2, so I'm just going to label every other one. 10, 12, 14, 16, 18, 22, 6, 10. Alright, like I said, whatever you use, it will be fine as long as you cover the largest of the y-intercepts. And now in terms of the graphing, my first inequality is x is greater than or equal to 0, and then the second one is y is greater than or equal to 0. Well, I know x is greater than or equal to 0 is this vertical line. It's actually the y-axis right here. So I'm just going to make it darker, or you don't need to do that. You just need to know it's sitting right there. And that is my first inequality. Second inequality is actually the x-axis. It's the y is greater than or equal to 0. Again, you don't need to make it darker if you don't want to. There's the second one. Third one now, my y-intercept is 20, so I'm going to go up to 20, put a point there, and then I can see that my slope is -1/2, so I'm going to go down 1 tick mark, even though it's really technically going down 2. As long as I do it for both axes, it'll be fine. Go down 1 tick mark, and then 2 tick marks to the right, which would put me right about there. Go ahead and draw a line through those 2 points. And this is inequality number 3. Now so far the first two told me to shade up in this first quadrant. This third one says shade below it. So as of right now I'm shading this little triangle here. Alright, I go to graph my last one. Notice that the y-intercept number is 24, so I'll go up to 24, put a point. Slope is -2/3, so move tick marks again. It's 1, 2 tick marks down, and 1, 2, 3 tick marks to the right. That'll put me right about there somewhere. Alright, and then I draw that line. And when I say you have to be somewhat accurate, you can see if I had this slope of this last one off just a little bit, they wouldn't intersect, and they're supposed to. So you do need to be a little bit careful when you're doing this. Make sure that you have uniform tick marks and all that, otherwise you may end up with some trouble. Alright, this one, fourth inequality, said to shade up. So for this one I want to shade above it, which means I was looking in this triangle. Shading above this line means I'm actually looking at just this tiny little triangle in here. And these are the vertices that I want to find. So that's the first thing. Make sure that you can rewrite your inequalities and then get the graph that you're looking for. Now I want to find these three vertices that define that triangle. And remember what we always said, look for vertical or horizontal lines. I can see I have a horizontal line running through these two. So for both of these points, I know that the y value has to be 0. And I know we're not looking for it, but let's say I was looking for that point. That's a vertical line that runs through it, so I would know the x value is 0, for example. And then I could figure out the y value. I don't need it because it's not defining our feasible region or our shaded region. Alright, once I get those two numbers, then look at what line runs through it. If you look at this point and you follow this line, you can see that it's inequality number 4 that I got that from. So I'm going to take the 0 that I know is the y value, and I'm just going to plug it in for y in that equation. I'm going to pretend like this is an equal sign now and try to solve it. So I have 0 is equal to negative 2/3 x plus 24, and now I just need to solve. If you really wanted to, you of course got that from this equation. You could plug 0 in for y and solve, which would be a little quicker, but this shouldn't take you that long either. If I do plug 0 in for y, this term disappears. I would divide by 2. It looks like it's 36. Same thing's going to happen here if I subtract negative 24. They're both negative, so I can ignore that. If I multiply both sides by 3, I get 72. And divide by 2, I get 36. So either way it'll work. I would suggest picking the one that you have y is equal to, but yes, it obviously will work if you went back to one of the original ones. Alright, so I know the x value is 36, so we'll write that down. We'll do the same thing for this one. I know the y value is 0. Follow that line, and you can see that it's line number 3. So go over here to equation number 3 and plug 0 in for y. So if I plug 0 in for y in that equation, I get 0 is equal to negative 1/2 x plus 20. And same thing, if let's add 1/2 x to the left side this time. Add 1/2 x, multiply both sides by 2, I can tell that x is equal to 40. And now I've got the points that I'm looking for. I do need this one, and unfortunately I don't have a horizontal or a vertical line that runs through it, and that's fine. Now what you need to do is take a look at which two lines run through that point. Well, it's lines number 4 and 3. So what do? You take equations number 3 and 4 and you set them equal to each other. And that's why this is in the section with all the systems of equations, because that's what you're solving. So I'm going to take negative 1/2 x plus 20, and I'm going to set that equal to negative 2/3 x plus 24. And I can do that because they are both y is equal to, so it's just making a substitution. And now I'm going to solve it. If you prefer to get rid of the fractions because you don't like working with fractions, go ahead and multiply everything by 6. I think I'm going to do that to make everything a little easier. That's going to give me negative 3x plus 120 is equal to, 6 divided by 3 is going to give me 2, so negative 4x. And then 6 times 24, if you need to multiply it out, you're always welcome to do that. Otherwise, if you can do it in your head, that's wonderful. You get 144. And now if I add 4x to the left side, that gives me 1x. Subtract 120 will give me 24. I now know the x value here is 24. Whoops, let me redo that. X value is 24. If I want the y value, I should be able to plug 24 into either one of these equations. We're saying that they were equal, so they should give me the same number. Now, when you look at your graph and you say to yourself, does 24 make sense? Well, I mean, according to my tick marks, it probably should be over here more, but again, we're graphing this by hand, so it's going to be off slightly. 24 does make sense because it is going to be somewhere to the left of 36. Again, it probably doesn't match up with my tick marks. If I had negative 24, that definitely wouldn't make sense because it should be over here somewhere. Alright, so plug 24 back in for x. I'm going to pick this equation. It's going to give me negative 1/2 times 24, or negative 12, plus 20, and I get 8. And I will get the exact same thing if I plug it in here. Now I've got the vertices. So now to find any possible max and mins, now is where the objective function comes in. So I'll write that over here. Z is equal to 4x plus y, and we are simply going to plug all these x, y values in to that equation. So if I plug 24 and 8 in, it is going to give me a value of, I'll go ahead and use my calculator here. It's got 24 times 4 plus 8. It's going to give me a value of 104. If I plug 36, 0 in, it's going to give me 4 times 36, which is 144. And if I plug my last point of 40, 0 in, that is going to give me, I guess I could do that without a calculator, that is going to end up giving me, what's not right? 160, I guess we already know that. And now if you're looking for your maximum, there's your maximum. I have a max at 40, 0 of 160. And if you're looking for a minimum, you would say I have a minimum at the 0.248 of 104. So kind of a lot that goes on, but you have to be really careful with your graph because a lot of your graphs are going to be very close like that, where if you're off a little bit on your slope, you end up not getting the right function, so be very careful. Alright, so on to the back one. Again, it's the same type of problem. The only difference is I've got to be able to get the inequalities myself. And so we're going to read through and see if we can't find some important information in there. Alright, it starts by saying a fruit grower has 150 acres. That's going to be important. Alright, has 150 acres available to raise two crops, A and B. A we are going to call X and B we'll call Y, just so that I have X's and Y's when I go to graph it. It takes 1 day to trim an acre. Notice that it's talking about acres. This was talking about acres. So when it says it takes 1 day to trim an acre of crop A, that's like saying 1X. And 2 days to trim an acre of crop B, that's like 2Y. And there are 240 days available. So that is going to be important. Alright, it also goes on to say it takes 0.3 days to pick an acre of crop A, 0.1 day to pick an acre of crop B, and there are 30 days available. Kind of like what this one said for the trimming, this is doing for the picking. That is going to be important. And then it says the profit is $140 per acre for crop A, $235 per acre for crop B, and they ask you to find two things. It asks you to find what is the optimal acreage for each fruit, which is basically telling you to go through this whole process and figure out which one's going to give you the max. Optimal profit, you want to make as much as you can. If it was optimal cost you want to be low, so you'd want the minimum, but this one wants the maximum. And then the other thing it's asking me is, what is the optimal profit? Meaning, I have to find the objective function, which in this problem they gave it to me. So my recommendation is find the objective function first all of the time. And how you're going to find it is basically looking at one of the last two sentences. What is it asking you to optimize? It's asking you to optimize profit. So when I go to write my objective function, it is asking for maximizing profit. So when I go back and read through this paragraph again, I'm looking for the numbers that are going to have the word profit in them, and that's right here. The profit is 140 per acre for crop A, which remember we're calling X, and 235 for crop B, which we're calling Y. Those two numbers are going to be in the objective function equation. So my objective function is always Z is equal to, and then it's 140X plus 235Y. There's the objective function. I'm going to need that to answer the optimal acreage for each fruit anyway. Alright, so that takes care of this, and then basically you can ignore those numbers now. The 140 and the 235, those are only a part of the objective function. Now the other stuff that I have circled or a box around it, that is going to give me the inequalities that I'm looking for. So now this would be the objective, or the constraints. You don't have to call them that, but these are the inequalities. Fruit grower has 150 acres of land available, and there's two crops, X and Y basically. So we are saying that X plus Y, if you have 150 available, it means you can't use more than that, so it has to be less than or equal to 150. If we move on and look what I have circled here, it says it takes 1 day to trim an acre of crop A, so 1X, plus 2 days for crop B, so 2Y, and it says that there are 240 days available, so I can't go over that, so it's less than or equal to 240. Same thing for this one when you look at talking about the picking. It's 0.3 days for crop A, so 0.3x plus 0.1 day for crop Y, or I know it says B, but Y is what we're referring to. And then it's 30 days available, so it's less than or equal to 30. And those are the inequalities that they just outright give you. Now, if you think about it, it makes sense, and this is in there for most every problem that you do. What's the minimum number of acres you can have? Well, 0. So even though they don't give you this, these two are kind of a part of it. So those are your inequalities. And like we did for the last one, I'm going to want to set these all equal to y or x for that one, and then graph them. So just rewriting these, I'm going to put these two down first since they're the easy ones. I've got x is greater than or equal to 0. Y is greater than or equal to 0. That again tells me I'm in the first quadrant. If I solve this one for y, that one's simple enough. That's going to be y is less than or equal to negative x plus 150. If I look at the second one here, or this is going to be number 4 here, if I solve for y, subtract x, divide by 2, so y is going to be less than or equal to negative 1/2 x, divide by 2, that should give me 120. And then I guess what I would recommend for this one, so I don't have to deal with the decimals, is multiply everything by 10. So it's 3x plus 10y is less than or equal to, whoops, I guess that would be 1y, wouldn't it? 3x plus 1y is equal to 300. And then you'll see it's actually not that difficult to solve for y. It's y is less than or equal to negative 3x plus 300. Alright, now I've got the inequalities. They're all solved for y. It should make it a lot easier to graph. And again, you're noticing that my largest y value, or y-intercept, is 300. So make sure that you cover 300 when you graph this. So you can go by 100s if you want to, and just try to be accurate with your tick marks. And that's basically what I'm going to do, is I'm going to do 1, 2, 3 giant tick marks. 1, 2, 3 giant tick marks. I'm going to go back in and kind of cut those in half, so I'm actually going by 50. And I'll just label the 100s. Alright, and if you want to, you could go back in and put 25s, not necessary. Alright, the first two I know are that line and that line, the two axes. I'm not going to go ahead and label them, but if you want to, you can. The third one I have a y-intercept of 150, which is right here, and a slope of negative 1. So go down one tick mark to the right, and that should give me something like that. Now, if I was graphing overly accurate, it should go through 150 if you think about it, but again, it's by hand. I just have to try to do the best I can. Alright, the more accurate you can be, the better. Alright, the number 4 here, I have a y-intercept of 120, which I'm going to say is right about there. Again, have to approximate a little bit. Go down one tick mark, 2 tick marks to the right, and go ahead and graph that line. And that was number 4. These are all less than, so right now I'm shading this little chunk right here. And then the last one, I have a y-intercept of 300. Slope of negative 3, so down 1, 2, 3 tick marks, to the right 1, 2, 3 tick marks, or realistically it should be going through 3. Here we go. Sorry, go down 1, 2, 3 tick marks, go 1 tick mark to the right, graph that, and it looks like it's hitting right about here somewhere. So if I could draw that a little bit more accurate, it looks like I have something like this. Where I have these two lines intersecting, and then this one should realistically go through 100. So that line's not actually there. So I have 1, 2, 3, 4, 5 vertices that I kind of need to find. Alright. Now I can tell that this one's 0, 0. I don't need really to do anything to help me figure that out. I know because of the horizontal line, I know the y value is 0 here. So I'll go ahead and put 0. I can see that the x value is actually 100, or look back, this is line number, I didn't write it, this is line number 5. If I plug 0 in for x, or sorry, y, if I plug 0 in for y, subtract 300, divide by negative 3, I'm going to get 100. So there's that point. If I look at this point, I am going to have an x value of 0 because it's got a vertical line here, so I know the x value. If I plug 0 into equation 4 for x, it gives me 120. Makes sense because I used that point. It was the y-intercept when I graphed it. So those are the 3 points that I have that are the easy ones to find. And then I've got these two. And so I'm going to go ahead and find both of those points. Looking at this one, it's equations 3 and 4 that are intersecting here. So I'm going to take equations 3 and 4, set them equal to each other, and go ahead and solve. So I'm going to add 1x over to the right, which will give me a positive 1/2, subtract 120, which will give me 30, multiply both sides by 2, and I get x equals 60. So this point has got an x value of 60. Plug that into either one, whichever you want to. If I plug it in here, I have negative 60 plus 150, or that's going to give me 90. Plug it in here, you get negative 30 plus 120, and again, it gives me 90. It should happen that way. Alright, for this one, it looks like it's lines numbers 3 and 5 that are intersecting. So I would take negative x plus 150, set it equal to negative 3x plus 300. And if I solve, if I add 3x, I would get 2x. Subtract 150, I get 150. Divide both sides by 2, I get x equals 75. And then plug that into either one, it looks like I also get 75. And now what you're going to end up doing is you're going to take all 5 of these vertices, plug them into your objective function, and see which one ends up giving you the largest number. And so we will go ahead and do that. Now I think it's pretty obvious that if I plug 0, 0 into this objective function, it's going to give me 0. I'll go ahead and write the objective function down here again so you can see it. So if I plug 0, 0 in there, I think it's pretty obvious that I'm going to end up with 0. If I take 0, 120, plug 0 in for x, take 120 times 235, that gives me 28,200. If I plug 100, 0 in, just multiplying that by 100, so tack 2 zeros onto it, would be 14,000. If I looked at 75, 75, I am going to end up with 140 times 75 plus 235 times 75, and that's going to give me 28,125. And then I've got 1 point left, and that's 60, 90. As of right now, this is my max. So I have 60 and 90, so 140 times 60 plus 90 times 235, and that gives me 29,550. And so that clearly is the largest one. So to answer the question, it says, what is the optimal profit? Well, my optimal profit is $29,500. The other question asks, what is the optimal acreage for each fruit? Well, remember what X was. X was crop A. So it looks like I would want 60 acres of crop A and 90 acres of crop B. Alright, good problem to look at. Look at a couple things. Make sure that you can read through it and find the objective function and the inequalities. And then once you've got the inequalities, make sure that you can solve them, find your graph, and then run through and find out the max or the min if they ask for that one. All right, that's homework help for section 7.6.